to talk, will you please leave? I'm going to record. So, well, she's... Anyway, are you ready? Or did you get one? So, we've only done one section on the logs, and pretty much what we learned how to do was the log loop, where you took logarithmic form and wrote it as exponential form, right? The base down here raised to that power equals that number. So this means 6 to the second equals 36. Obviously that's true. And then we went the other way and we wrote this in logarithmic form. And really, there wasn't any work to show for those two things, right? You just went from one form to the other. That was fairly simple once you just got used to the log loop. Then the other thing we did was simplify these. And remember what we did? We set it equal to x, and then we used the log loop. And we did 2 to the x equals that thing. And then what did we do? Like bases, right? And always, for all of these, like bases, like bases, like bases. So that was it. That's about all we've done so far. We don't know how to do very many operations. There's a button on your calculator that has log, but that's only log base 10. So today we're going to use these laws of logs. They're in your book, but I plan to leave those up here through the whole chapter. The laws of logs have some ways that you can work with them. One of them, if you have a product of two numbers and you're taking the log of that, the rule says that's equal to adding up the log of each one separately. So the log of m plus the log of n. And they probably won't make much sense now when you look at them, but later on when we do some examples, hopefully they'll clear it up a little. The second law has to do with quotients, dividing two things. If you're dividing two things and you take the log of it, the rule says it's equal to the log of the top thing minus the log of the bottom. So multiplying, you add the logs, and dividing, you subtract the logs. Another one of the laws of logs has to do with exponents. If you have an exponent up here, the law says you can just bring that exponent out front, take the log of just the number, and then multiply that log by the exponent. And then the last one really isn't in the book, but I wanted to make sure you knew. You probably already know this, but if I take some base and raise it to the 1 power, I'm just going to get that number back, right? Like 10 to the first is 10. So, in other words, what is log base 10 of 10 equal to? 1. What is log base 2 of 2 equal to? 1. Because 2 raised to the 1 power. What is log base 5 of 5 equal to? 1. And they assume that you know that, right? But you know what happens when we assume too much. So starting way down there, you're going to use the laws to do a couple different things. This one says you're supposed to start with this m squared, n to the third, take the log, and you want to rewrite that as separate logs. You want to break it apart and write it as log of m and log of n. So what you have to do is ask yourself, is it a product, a quotient, or an exponent? Is this a product, a quotient, or an exponent? Is this a product, a quotient, or an exponent? It's a product, right? Well, it does have exponents too. So since they have separate exponents though, I think I would deal with the product part first. Product is rule number 1 over there. And rule number 1 says I can take that thing and write it as the first one plus the log of the second one. Would you agree with that?
Sure.
It's rule number 1 says if you have a product of those two, it's equal to the log of this thing, that'd be this part, plus the log of that one. Agree? And now she says we have exponents. Now I would deal with those exponents. That's rule number 3. What does rule number 3 say I should do with the exponent? Move it out front, right? So that would be equal to 2 times log base 6 of m. And this one would be 3 log base 6 of n. And that would be my answer. I don't really have to do any computing. I just have to rewrite it again. But I would say you probably need this step in the middle before you rewrite your final answer. Would you agree? Here's another one. Same thing. I'm going to take this whole big log and separate it into m and n. So, if I have log base 2 of a root of, how do I write square root again? 1/2 power, she says. So, would you agree this would be, instead of a square root, I can raise it to the 1/2 power? Right? And if it's outside, doesn't it go with both of those? Oops, I think I made a mistake. Doesn't it go with both of those if it's outside? Doesn't it go with both of those if it's outside? So what would that be? Log base 2 of m to the 1/2 and 5/2, she says. Like that. Now what? I think I would deal with this first, again, because they have different exponents. And someone in the earlier class said, couldn't you take this and bring it up? Yes, you could. You could do that, and you get the same exact answer as if you don't bring it up. What does the rule say about the quotient? Subtract. So it'd be log base 2 of m to the 1/2 minus the bottom one, sorry, it's a little close, log base 2 of n to the 5/2. And now what about the exponents? Put them in front. So I'm going to take this and write it out front. That'd be 1/2 log base 2 of m minus exponent, put it in front, 5/2 log base 2 of n. And that would be my answer. And by the way, if we brought this up, that'd be log base 2 of m to the 1/2 and n to the negative 5/2 if we bring it up, right? And so what does the rule say about the product? You add them, so log base 2 of m to the 1/2, and you're going to say, hey, wait. It's supposed to be a minus there. Well, what happens when you bring that exponent? Well, this one is going to be just 1/2 out there. What's going to happen when you bring that one out in front? It's a negative 5/2, and guess what? That'll be where the negative comes from. So either way you do it, if you want to bring it up and make it negative, or if you want to use the quotient, either way you'll still get the same answer. Does that make sense? Questions so far? Now we're going to go the other way. These have them separately, and you have to write it as a single. So now we're going to be starting on this side, and we're going to go to the opposite side. So we're looking for adding, subtracting, and a number out front. Adding, subtracting, and a number out front. This one looks like it's adding. Oh, but wait, I have that number out front. What is the number out front? Yes. So I think I would leave this alone. This one is the exponent. Would you agree that it's going to be log base 10 of q to the 3rd? Yes? And now it's an adding. What rule over there is adding? The multiply one, she says. So how would I write that? Log base 10 of? Right, the rule says if you're adding each one separately, it's like their product, the log of a single product. So that's just your answer then. That's all you have to do. That's not too bad, right? How about this one? Can we move it over and move it over? Log base 10 of p to the minus log base 10 of q to the. It's a minus. What rule is minus? Yeah, number 2, the division one. So, and you have to make sure that whatever one comes first, that has to go on the top. Whatever one comes second, that has to go on the bottom. There's your answer. I wrote it all together as one. That's all you have to do. Does that seem very difficult? Good. Do you have any questions so far? The rest of it, you're actually going to be finding values. And before we start, bless you, let me say that you're not taking out your calculator and typing it in, hitting the log of 18 equals, and then writing that number down. That's not what we're doing, and if anyone does happen to do that, you'll get a 0. They all will not be log base 10. Your calculator only does log base 10. So you need to know how to do these if you don't have a log base 10. And what you have to do, they will always give you some values. In this case, they gave us the log of 2, the log of 3, and then remember, one that they don't give you but they assume you know is what is the log base 10 of 10? It's 1. So we know the 2, we know the 3, and we know 10. Here's what your hardest part of these is going to be. This number that you want to log up, you have to figure out how to write that as a product, a quotient, or an exponent. A product, a quotient, or an exponent of 2, 3, and 10. Because those are the only values we have to work with. 2, 3, and 10. So the first one is an 18. You have to figure out how am I going to write 18 as a product, a quotient, or an exponent of 2, 3, and 10. And before you tell me, there might be a couple different ways we can do it. And no matter which one you use, you should be able to get the right answer. How do I write 18 as a product, quotient, or exponent of 2, 3, and 10? That's what you have to figure out. I'm not going to tell you. Say that again. Could be an exponent, right? Of what? Did you say you could write it as what? How can I write 18 with 2's, 3's, and 10's? And it can't be 2 plus 2 plus 2. It's got to be a product, multiplying, dividing, or exponent. 2 and 3 squared, she says. Does that work? 18 is 2 times 3 squared. Agreed? 3 squared is 9. 9 times 2 is 18. So that's going to be the hardest part. How do I write 18 using only 2's, 3's, and 10's, but they have to be multiplied, divided, or using exponents? Once you have that, now you're going to use the law of log. I have a product right here. Which rule is product? Log base 10 of 2 plus log base 10 of 3 squared. What do I do with the 3 squared? Bring it to the front. The rule says I can write that out. So log base 10 of 2, 2 log base 10 of 3. So I have to take the log of 2, which I know, what is it? That's 0.3. And I have to add to it 2 times the log of 3, 0.48. So 2 times 0.48, is that 0.96, I believe? And 0.96 I think, yes. So your answer then is 1.26. And by the way, did I mention you won't get credit unless you show me these steps? Not every single one probably, but you have to give me the gist of how to get to the right answer, other than just hit it on your calculator. Does that make sense? So how about this one? I need to know how am I going to write 20 over 3 as either a product, a quotient, or an exponent of 2, 3, and 10. And I'll give you a hint. The bottom number already is a 3. You don't have to change that. How are you going to write 20 using 2's, 3's, and 10's? 2 times 10, she says. Hopefully that's a fairly easy one. 20 is 2 times 10. What do I have? 2 times 10. What does the rule say? For the product, what do I do to the logs? Log 10, 2 plus log 10 of 10. But then I have a quotient, a 3 underneath. What do I do with that one?
Minus.
Right, subtract. Minus log 10 of 3. So, what is the log of 2? It's 0.3. What's the log of 10? 1. Minus, what's the log of 3? And I just did this one last hour. What does it come out to be? I think 0.82.
Yeah. Yeah.
But you can work it out. How about log 10 of 5? How am I going to write 5 using 2's, 3's, and 10's? That one should be easy, shouldn't it? It has to be 2's, 3's, and 10's, product, quotient, or exponent. Is that easy?
10 divided by
Really? Say that again?
10 divided by 2.
10 divided by 2. Isn't 10 divided by 2 5?
Yeah.
10 divided by 2. Right. Has to be multiplying, dividing, or exponents. No adding and subtracting. So once you have that, the rule says you subtract. So this is going to be log base 10 of 10 minus log base 10 of, right? What is the log of 10? What is the log of 2?
Point trace.
Oh, good, I can do this one in my head. Questions so far? I got one more quick one. This one has a root. It's a cube root. How did we just learn to write cube roots?
1/3.
So 1, 2 to the 1/3, and then can we bring that up? I would write it as log 10 of 2 to the negative 1/3 times 1. You don't really need that 1 there, right? The rule says I've got an exponent. What do I do with the exponent? Right? So this is going to be negative 1/3 times log of 2. What is the log of 2? What is the log of 2?
0.3.
Yes? Can I write it instead of 0.3? Could I write it as 3/10? If I write it as 3/10, then guess what happens? So it's equal to negative 1/10. Does that make sense? Does that make sense? Are there any questions?
Negative 2.
Okay, I'm good.